I don't really have a nickname yet. I guess I'll just say Neetc. No, I guess that doesn't really make sense. It's kind of like Neetcode. But basically, the idea of this channel is to go through all 150 problems of the Neetcode 150. And I have this wheel here that I'm going to spin every day. And I'm going to solve whatever problem that is. And I know that's not the smartest way to go about it, because you want to like build your way up from subtopics to bigger topics. But the point here is to make it funner and to get all the problems done, since I haven't really been that consistent. I think last time I leak coded was probably sometime last year, so it's been a minute. And right now I just have Neetcode open, chatgpt in case I need help, the wheel, and then Neetcode where I'm gonna solve the problem. Alright, let's get started. Spin that wheel. Rotate image. That sounds difficult. I've never heard of that problem. I have solved some of the problems, but not that problem. What would it even be in? How would I even search it? Let's try here. Oops. Rotate image. Okay, that's part of math and geometry. Okay, we're getting hit with math and geometry already. Alright, well, we'll do our best. So let's go ahead and want to solve it on Neetcode. Okay, let's search it up through here. Rotate image. Okay. Can I run my code? Does that work? Okay. So we're ready to get started. Let's look at the problem here. So rotate image. You're given an n times n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. I don't really know what I read, but let's just keep going. So this is example 1. It's just your regular grid, 1 through 9. And then after that, it gets like shuffled a bit. Can't really tell what happened just by looking at it. So it looks like we're given a list of lists. Okay, and then the edge cases or the constraints are n can only be equal to the max length. Wait, no. N is equal to the matrix length, and every sub list is also equal to the same length. So for example, here there's 3 elements inside of this list, and there's also 3 sublists. Okay, makes sense. So it's a 2D matrix. What's a matrix? A matrix is just a 2D array, I think, right? Pretty sure. You're given a 2D matrix representing an image. Rotate the image by 90 degrees clockwise. So that way. Okay. 90 degrees. So if we were to rotate this, it would just literally kind of like pushing a box over. So I kind of want to draw it too. Excalidraw. You don't know Excalidraw? It's like really good for whiteboarding. Whoops. I don't think I should have showed that. Oh well. It's really good for whiteboarding. So basically, I guess if this is our matrix There's no point in drawing it really, but let's just say we have 1 up here, 9 down here. I don't feel like drawing all of them. 1, 2, 3, 4, 5. We'll draw every corner piece. 1, 2, 3, 7. A little spacing out. So basically, if we're rotating clockwise, like a clock, you go this way. So imagine we drop the box, and it would look something like, whoops, that is not Windows security. What? Okay, so it would look something like this. We drop the box, 7 ends up here. What would it be? 1 ends up over here. 9 ends up over here. And what was it? 3 ends up over here. 7193. Let's see if that's how it looks. I should have double checked before actually going through this. Oh man, the recording thing's in the way. I need a control tab. Can't even do that. How do I get to that tab again then? Oh, there we go. So 7193, yeah. Okay, so that's basically what's happening. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix into the rotation. Okay, so we can't make another list of lists, and we have to do it in place, which basically just means by not altering the actual structure of the list. Is that how you would say it? Let's see what the definition says here. Let's see what they put. Redirects here. I have a long definition for something simple. Directly on the input data structure without requiring extra space proportional to the input size. In other words, it modifies the input in place without creating a separate copy of the data structure. Okay. Got it. So, how do we approach this? Let's see what we got here. We got a class called solution and a function rotate self matrix. So here's our actual list. It's a list of lists, and inside of the lists, said list so many times, are integers, and then we're returning nothing because we're modifying it in place. That makes sense. So how do we approach this? Let me think. What makes this also a little harder is that I don't have my glasses, but we're gonna push through. Okay, let me get comfortable. So where do I even start? I mean, let's see how far everything got shifted. For example, the 1 ends up 3 spots to the right. The 7 ends up 3 spots down. The 9 ends up probably 3 spots. Wait, hold on. The 9 ends up 3 spots to the left. And then you have the stuff in the middle. So if the 1 went all the way to the right, 1, 2, then the 2 went 1, 2. Yeah, I don't know what I'm talking about. We're gonna need some chatgpt. I know you're probably thinking this is taken away from the point of like learning, but I'm here to get the problems done and examine the solution. Not be a superhero, I'm sorry. I can't be that guy. I wish I could, but I can't be that guy. So, okay, so we have the length of the actual matrix. Transpose the matrix. What does that mean, transpose? Does transpose mean? To change the relative order, position, or sequence of two or more things. The word is widely used across different fields, including general language, mathematics, music, and grammar. Basically, to swap places or reverse two or more items. And in mathematics and what we're talking about, an operation that flips a matrix over its main diagonal, turning its rows into columns and its columns into rows. If a matrix is A, its transpose is written as A to the power of T. Okay, so basically, we just turn the rows into columns and the columns into rows. Interesting. I don't really know how that helps, but we'll find out. Transpose the matrix, so for I in range of n. So we're going to keep going into the length of n. For j in range of I plus 1 comma n, matrix ij, we're going to switch. So we're basically swapping them. And then we're going to reverse each row. Interesting. For row and matrix, row dot reverse. Let's see why this works. So here's the original 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after we transpose it, funny word, we're basically swapping everything, it looks like. I don't fully understand. So 1, 4, 7, 2, 5, 8, 3, 6, 9. Let me look at the code again real quick. Sorry if you were reading that. But I need to understand this. Let's see. For I in range of n. Okay, so we're going through the list, starting from 0 all the way to the list minus 1. Or the size of the list minus 1. And then for j in range of I plus 1. So this is the number right in front of this one. Interesting. Comma n. Yeah, I have no idea what I'm talking about. I'm going to have to copy and what's it called? Paste this. And then we'll figure it out here after printing. So let's put some print statements so we can figure out what's happening. So first off, let's comment here. It's just going to be the length of the matrix, so size of the array. Transpose the matrix, and that was basically when we turn the rows into columns and columns into rows, right? Is that always the case, or I'm not sure, but let's keep going. For I in range of n, so let's say n is 3 in this case. We're going to start at 0, then go to 1, and then 2. And then for j in range of I plus 1 comma n. So basically this j is 1 ahead of I. Okay. And we're going all the way to the same size, 3. So this is going to go 0, 1. And I'm using the example that we have this array right here. Let me write it up here. as well. That would make our n over here 3. So I'm just gonna like use this as the example. 3. This would end up being 3 because there's 3 elements in here. 1, 2, 3. Transpose into the matrix. Transpose the matrix. Speaking of Matrix, I should probably watch that movie. I just haven't gotten around to it. Even though it's been out for like longer than I've been alive. Maybe, possibly. What year did The Matrix come out? What year did The Matrix come out? 1999. That is an old movie. Everyone talks about it too. Or has mentioned it. You see all the memes online and stuff. But I have not watched the movie. Hopefully before I end this series, I have watched the movie. Anyways, let's keep going. So for I in range of n, it's going to go 0, 1, 2, not including the actual max size, or the actual like size of this. Remember how n is 3? So we're going to go 0, 1, 2, not including the actual number that we're going up to. And that's going to be every iteration. So, like for example, iteration 1, the first time we go through this is going to be 0. Oh, I is going to be 0. The second time, I is going to be 1. The third time, I is going to be 2. So on and so forth. So this loop is going to execute 3 times. And let's check this inner loop. For j in range of I plus 1, all the way to n. So we're basically starting from 1. Because I plus 1, so 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Some high level mathematics here, I know. And then I forgot what this means. When it has a comma here, it was like start, stop, end for for loop. I'm trying to remember. Pretty sure that's how it works. So this should probably run 3 times as well. It'll just be these 3. And the reason we include 3 this time is because since I here is going to be 2 at one point, which realize this is going to have a bunch of iterations as well, because it's going to run 3 times. Like this whole thing inside of here is going to run 3 times because the outer loop runs 3 times. So I guess I'll write that too. So I'm going to be more specific to iteration 1 is 0. Iteration 2 is 1. Iteration 3 is 2. Or I is, yeah. Should I be even more descriptive like that? Okay, we can. I don't think I'll be this descriptive for the harder problems, but I guess technically this would probably be a hard problem, or maybe not. I don't know. Let's just keep going. So for here, iteration 1, honestly, it's probably better to print this out. But I just like seeing the comments. I don't know, it just puts it better in my head. So for j in range of I plus 1 comma n, it's iteration 1 would be I plus 1, so 0 plus 1 would be 1. Then we go 2 and then 3. Okay. And then iteration 2 would be 2, and then 3. And then iteration 3 would probably just be 3. I hope I did that right. And then J for each of these. My room is so hot. I'm at an Airbnb right now for work because I work around this area. So if any of you know a cheaper place to look, let me know. Hopefully the guys didn't hear that. Anyways, J. Okay. So basically what's happening here is we're swapping them. So the element on the first element and the opposite element, Ji, they're gonna be swapped, and we're just gonna keep doing that, it looks like. That's so weird. Let me see if I can draw this. So I guess basically if we had this, if we basically had this matrix, we would basically be swapping I and J, with I every iteration being what was it, 0, 1, 2. So I can only be 0, 1, or 2 to represent every row. Just like imagine these were like the actual arrays. You know what I mean? Here's an array, comma. Here's an array, comma. Here's an array. Okay. And then it'd be this would be index 0, index 1, and index 2. And basically we're just swapping them. So what's going on here? I guess in the first iteration, what was it? I would be 0 and J would be 0 plus 1. So let's write that up here. Yeah, I do not feel like writing that. Let's just type it. I is equal to 0 and J is equal to 1. And then we're basically swapping them, remember? So it's going to be matrix I, J. Let me. Matrix I, J is going to be swapped with matrix Ji. I'm not rewriting that whole thing again. So let's just swap them. So they're being swapped. Okay, so they're being swapped. And let's see what that would look like. So in the first iteration, that would basically be I equals 0, j is equal to 1. So matrix, yeah, I ain't rewriting that whole thing. So let me just copy this. Let me paste here. So it'd be 0, 1, 1, 0. Hopefully later on we start using the print statements more. I'm sure that'll be easier. But I just need to like walk through it and visualize it just because I haven't done this for so long and too much brain fog. Too much brain fog. But regardless, we're going to get through this whole series. I can promise you that. I spelled matrix wrong too. I need my glasses. But I broke them. How did I break them again? Oh, I just like fall asleep with my glasses so many times that I finally got unlucky and one of the one of the side pieces, like where it goes on your ear from the frames, got broken. So unfortunately, I had to super glue it, and the super gluing takes some time for it to like harden. So I'm just kind of waiting on that. This isn't the first time I've done it for that pair. I'm waiting for my new glasses to arrive. Got myself some new glasses, some Ray-Bans. So we'll see how they look. Anyways, I'm getting off the track. Where was I? So this is how it will look for the first iteration. We're basically swapping matrix 0, 1. So 0, 1 would be, it would be inside of here because the first part is 0. So we'd go to array 0 and then 1, which would basically be this one because we start at 0, it'd be 0, 1. So this guy over here is going to get swapped with 1, 0, which is 1, 0. This one. Right? 0, 1. So 0, 1, 2 is going to get swapped with 1, 0. Yeah, okay. And then, yeah, that's all that happens. 4 and 2. That's what we should have now. I don't know how to copy this. Let me figure it out. So maybe if I do this, copy this. Perfect. That's so useful. Anyways, so basically we would swap them. So now it would be 4 over here and 2 over here. Okay, and that's in the first iteration of the outer for loop and the first iteration of the inner for loop. So next we would go to the next one, which would be matrix will still be 0, or I would still be 0. So let's wherever we see I, we'll keep it 0. So 0, perfect. We're only switching the ones. So now this is gonna become 2. This is gonna become 2. This is gonna become 2. And this is gonna become 2. So let's see how that would look. So now let's go to the next one. Matrix 0, 2. So I could draw them up here so it's easier to visualize. 1, 2, terrible written numbers. 3. Oh, wait, no. It'd be, my bad. 0, 1. Could we start at 0? Isn't that weird? 0, 1, 2. So we'd basically swap 0, 2. So this array 2. So this 3 would get swapped with, what was it? 2 0. So down here, 0. This 7. Okay. So let's see how that would look. Whoopsies. Okay, so let me write it down here. Oh, I could have just done the arrows, but anyways. So these would be swapped. So much work. So the 7 would be up here. The 3 would be down here. I don't blame you guys. If you guys click off, I'd be so bored watching this. Be like, why doesn't this guy have its things in order? So 7 and 3, it looks like this. Okay, 7 over here, 3 over here, 4, 2. I don't really know what's happening. We're basically switching the rows and the columns, like the video said. So our row becomes our column becomes our row. We basically did that for everything here. And I guess it kind of makes sense, right? Kind of. Let's think about it. So we basically had this number over here, which was all the way in the top corner. And by swapping its row and its column, swapping the rows, what does transpose mean again? Like, it was swapping the row as the column and the column as the row, I think. An operation that flips a matrix over its main diagonal, turning the rows into columns and its columns into rows. If matrix A is 1, 2, 3, 4, then the transpose is 1, 3, 2, 4. Okay, because this switches with its I don't fully understand. I'm having a hard time figuring out transposing. Explain it simply. Across its main diagonal. The main diagonal is the line from the top left to the bottom right. Codex. Interesting. But not today. So diagonal number is 159. When you transpose, the diagonals stay the same and everything on the opposite side swaps. So 159 changed to stay the same. So 3 and 7 swapped. 2 and 4 swapped. Oh, I think I get it now. Kinda. Why is it so useful though? Or how is it so useful? Other than for solving this problem. Doing half the rotation in a clean way. Because it turns columns into rows, and rotation is mostly about moving columns into new positions. Explain. Turns columns into rows, and the rotation is mostly about moving columns into new row positions. Who invented it and for what? So Arthur Cayley created the matrix transpose. He was a British mathematician from 1858. He was one of the main people who developed the early matrix theory. The word matrix itself was introduced early by James Joseph Sylvester, like Sylvester Stallone from Rocky. If you haven't watched that, you should totally watch that. In 1850, a transpose was not invented for rotating images or solving Neetcode problems. It came from math. Originally, matrices were useful for organizing numbers that represented things like systems of equations and linear maps and geometric transformations. Can represent transformation like stretching, flipping, rotating, or projecting points in space. So it was basically used for flipping and rotating and some other stuff. And it gets a clean way to swap the role of rows and columns. So rows become columns. Because like this 1, 2, 3 gets swapped so that it's the column this time. Rows often represent one kind of information. Columns often represent another kind of information. Transpose lets you switch the perspectives. So it's useful for rotating images, flipping grids, working with spreadsheets, machine learning data, graphics, and matrix math. For here, it's useful because we're just turning the rows into columns and the columns into rows. Long explanation, but very useful. Okay. So is that what's happening? 1, 2, 3. What does the final thing look like again? 1, 2, 3. 1, 2, 3. Let me see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, okay. I think I get it now. I was just overthinking this too much. But basically, like they said, it's transpose turns the rows into columns and the columns into rows. It's so simple now that I think about it. So for example, this row 1, 2, 3, it gets sent to the back, and it's literally from bottom up, from top to bottom, 1, 2, 3. So the 0th row becomes the last row. The last column. And then what's it called? 2, 5, 8. Never mind, I lied. I don't know what I'm talking about. Wait, 4, 5, 6 stays the middle, and then 7, 8, 9 becomes the front, apparently. I don't understand why this row doesn't just go 1, 2, 3, like starting from here. Like 1 up here, 2 here, 3 here. I guess it's just the way they flip it. Because the video said that... I'm trying to remember. Or not the video, the chatgpt. How to explain it. Point is, it works. We're basically just switching these rows into columns. For example, this 1, 2, 3 ends up 1, 2, 3, but as a column. This 4, 5, 6 as a row ends up 4, 5, 6 as a column, and this 7, 8, 9 becomes 7, 8, 9 as a column. Okay, so we get this part. That's what's happening here. And then after that, we're reversing each row for row and matrix. Row dot reverse. So now we're switching the actual numbers themselves. So originally, I guess this looked like, let me just print it out. Print matrix. And then print matrix. Oopsies. That's spelling error. Okay. So, yay, we solved it. But let's look at what happens here. 1 4 7 2 5 8 3 6 9. And by the end it looks like this. So 1 4 7 2 5 8. I need to draw this. So hard to visualize. Okay, we're getting there. We're getting there. So you know what I could do? I just realized I'm learning as I go, guys. I'm learning as I go. I promise I'll be better by like the 100th video. But I'm still learning. Like, look at me advancing. Oops. Before I was drawing them out and stuff. We're getting better and better, guys. Who knows what I'm gonna be like by the end? It's limitless. Okay. The potential is limitless. 1. Oops. That is way too small. So 1, 2, 3. Let me just copy this too, because I'm not trying to redraw this. This will be my template one. So that I could use it over here. Over here. Over here. Over here. OP. So we have 1, 2, oopsies, 3, 4, 5, 6. My hand's cramping. 8. We gotta commit. 8, 9. And usually what happens with transposing, it says you flip everything across the diagonal. So I guess this stays the same. And then everything here flips. So 2 flips with these 2 flip. Whoops. These 2 flip. 2 and 4. And then these 2 flip. 6 and 8. And then these stay the same. 1 and 9 stay the same because they're on the end. So it just flips across the diagonal. So it should look like, I hope it looks like this, because I'm not trying to redraw this again, low key. It should look like this. 1, 4, 3. Hold on, my hand's cramping. I couldn't commit. I was weak. I showed weakness. I'm sorry, guys. 2, 5, because it stays the same. And then 8, because we swapped them. And then 7, because that stays the same. And then 6. And here is 9. So 1, 4, 3, 2, 5, 8, 7, 6, 9. And then after that, we reverse everything, like the thing said. Row dot reverse. We reverse each row. So after we reverse them, it would look like, I lost my train of thought. 3, 4, 1. That's how it would look like reversed, this row. 3, 4, 1. 8, 5, 2. 9, 6, 7, 6, 7. 9, 6, 7. So is this how it's supposed to look? So we flip it. 3, 4, 1, 8, 5, 2. Yeah. Let's see here. So brain fog, guys. 3, 4, 1. No, I did not cook. I'm sorry, guys. What did I do wrong? Let me see how it looks for the first one. 147. 143 is what I got. So I guess this does swap. I lied. I'm sorry. I lied. I thought that diagonal stayed the same. I guess it was just for that one example. These swapped as well. So does the 5 in the middle stay the same? 147. 258. No, that's correct. 258. Oh yeah. And then so I guess I was wrong. The diagonal doesn't happen from this way. It actually happens from, let me erase this. It happens from, where is that line? Here it is. It happens from this way. So these stayed the same, apparently. And then these also got swapped. So the 3 and the 7 got swapped as well. This one got swapped with this one. So it should look like 7 and 3. And then these stay the same. So 147, 258, 369. So we flipped across this diagonal actually. Why? I'm not fully sure. That's a good question. Maybe one day I'll come back and just really try to understand it fully. Okay. So I guess after flipping everything, luckily I drew 2, because I'm not trying to draw it again. Whoops. So after flipping this, it would look something like 7, 4, 1. Wait, what? 7, 4, 1. Is that even right? 7, 4, 1. Yeah, it is. Okay, whew. I thought I was cooked. 8, 5, 2, because we reversed that. And then 9, 6, 3. And then here's our answer. I guess I took a not too complicated problem and made it much more difficult than it should have been, but we got there. Basically, we had this array, this matrix, so a 2D array, and we wanted to rotate it, so 90 degrees. So imagine this falling forward as a box, like that. Well, not this one specifically, more like this one, but you get the idea. And after that, we wanted to, how we do that is we transpose it first, which is just swapping the rows as the columns and the columns as the rows. So that's transposing, and we do that by flipping it across its diagonal. So from here, 159, those stay the same, and then we just swap it. So 7 goes where the 3 is, 2 goes where the 4 is, so on and so forth. And then after that, we just reverse it. Alrighty. So is this the same thing? Let me see. So we have this up here. Imagine the box falling. Yeah, okay, 90 degrees rotated. So 5. So let me see here. I want to copy this, but I don't know if I could do that right now because I'm already recording through the snippet, so I can't really take a snippet of it and then copy paste. So let's just imagine this. So 5, 4, 6, 16 is our diagonal. That stays the same. And then after that, we flip everything across it. So 1 swaps with 2. 9 swaps with 13. And then 11 swaps with 15. So now it's 5, what is it? 2, 5, 2, 13, 15. 5, 2, 13, 15 for the first row. And then we reverse that 5, 2, 13, 15. So it becomes 15. Here it is. See, 5, 2, 13, 15. It gets reversed and it looks like this right here. And we basically do that for everything. So we transpose it, which is changing the rows as the columns and the columns as the rows. For example, how everything gets shifted over here. So like 5, remember? Okay, I get it now. I get it. So how this 1 moved over here, this 9 moved over here, and this 11 moved over here. And we basically moved this whole row over here as the column. And then after that, we just reversed it. I don't fully understand why the reversing worked. I get the transposing now. I don't fully get why we reversed it. Why did we reverse it? I'm not fully sure. I just know that it worked. Anyways, yeah, if you have any, I'm not even gonna say questions because I was struggling out here. If you have any answers, let me know in the comments. And let me just submit this real quick. So yeah, if you have any answers, submit them in the comments. And we're gonna keep going with these. Like we just did rotate image. So that's 1 out of the 150. So that means we have only 149 to go. So something light. And let me just cross it out over here. I've solved some of the problems, mostly the easier ones, like the ones in here. So when we get those, it'll be nice to like just chill and do those. But the main idea behind this channel is just to get all the Neetcode150 problems done. I know it's not the smartest approach to just do them at random and figure it out as I go, but I need to get them done, and I've been slacking for a long time now. So this is my way of doing it. We're gonna get stacked before fall time, interview season. So yeah, 1 problem done, rotate image. I hope to see you tomorrow, and take care. Peace.